We did it. We migrated to Kubernetes. Before Kubernetes, we were running on static servers, which was problematic. We had to always be scaled up just enough to ensure that we could hit the demand of the traffic from our customers. With Kubernetes now, we have the ability to auto scale up automatically, which is fantastic. Having to manually scale up and down, that's a lot of work that the computer could do for you. Why would we need human to look at the chart? Well, I'll look at the chart and say, okay, do we need a server there? I don't know. Maybe it seems like we might be okay. And then decide to launch another server. That's the great part about Kubernetes, is it will do it for you automatically, and it's fantastic. But there are problems, and one of them, let's just go straight off. We talked about scaling up. Well, guess what? It scales up. It does that really well. It doesn't scale down as easily. So as pods need to grow through the HPA, horizontal pod autoscaling, they will add new pods, they'll launch new nodes, add more pods. That's great, we've scaled up. However, once we scale down, it'll start scaling down and sort of take down the pods first. But the nodes, they usually stay running. They stay running for a lot longer. And so it means that you're actually spending more money for those servers, even though you're not even using them. So that's one of the challenges. That's one of the 3 challenges that we have with Kubernetes. Another one, that's just when we first got started with Kubernetes, it's a whole new sort of paradigm, right? If you're used to operations and the servers and the CPU utilization, well, guess what? It's the same thing, but everything's a little bit different. There's this thing called, the liveliness probe and the requests for resources versus the limits of resources. Those things are different and they have different meanings. One is specifically tied to C groups, which will intentionally throttle and prevent your application from going any further. The other doesn't actually do anything other than just figure out where it should schedule a pod. We didn't know which one was which. So, the requests, we're like, oh, we just put a high request and then match the limit. Basically, we're doing nothing. We're not taking any advantage of the tier between those two. So if we take the limit, set it at 1 core, that means that pod will never go above 1 core, because C groups in Linux is going to prevent it from consuming any more beyond that. Then with the request, it's only going to use that to help schedule across nodes. So if you have an 8-core server and then you schedule a pod, 1 whole core CPU, then it's going to schedule 8 pods on that server, even if those pods don't use that CPU. And so now you have a problem, right? You've actually got a pretty big problem. You got a spend problem. And this is one of the biggest problems with Kubernetes, is you're just paying for the server hardware that you don't use. You won't be using it, because those applications, even though you've set them to use 1 core, they might not do that. They just might not. And so you're stuck with these servers with low utilization. The 3 problems that everyone's gonna have, that we faced immediately when we went to Kubernetes, is the cost. It gets really expensive. It scales up really easily, and scaling down, it doesn't do that as much. It will, but not as quickly as you want it to. The second one, the uphill challenge of just learning the nomenclature, all the little details of Kubernetes, because if you're used to standard Linux and the operations of a server, guess what? It's the same thing in Kubernetes, but just a little bit different. And there's all these nuances, and they all have these different, it's just an uphill battle, and everyone has to learn. What was the final challenge? Is tuning autoscaling, because it's not obvious what those autoscaling patterns are and what the different levers are. So you've got horizontal pod autoscaling and vertical pod autoscaling. Most of the time you want horizontal. And when you do that, you have these two levers for resources. One is called a request and one is called a limit. And they're both different and they have different meanings. One is very tied to specifically holding back, preventing it from using any more. The other has nothing to do with restrictions. It's just all about scheduling, right? The requests, it's all about scheduling. Go on these servers, you go over those, you go over those servers. And if you don't use the resources, they just won't get used. And no additional pods will get scheduled. And so you have a low CPU utilization problem. And so those are the 3 challenges that we had with Kubernetes. We're doing good now. We still could optimize a little bit more, we could optimize a lot more. A lot more. There's a lot of opportunity there.